Thank you very much. I had my own kind of intro. Hi, I'm Mark Smith, and I will be your MC for the first PyCon UK Lightning Talks for 3 years. So, thank you to everybody who put your submissions in earlier today. We have 10 fantastic sounding lightning talks. We have 5 new speakers and 5 more experienced speakers. We kind of interleaved them so that we've got a good mix of experienced and new speakers. But the rules are the same for everybody who's speaking. So, and I, as everybody knows, I rule this with an iron fist. So, when people start speaking, there's no applause at the start. There's often a temptation, but we've got to get through. We're already late, so I'm really rushing through this introduction. So when people start speaking, they just start speaking. We save the applause to the end. And I know it's been a long day, and I know some people traveled in this morning, so we've had hours of travel potentially, and then we've had a whole day of talks, fantastic PyCon UK talks, workshops, and we're all maybe a little bit tired. But we can't afford to do that because this is the best bit of PyCon UK. So, when we applaud, I said this morning, if anybody wasn't here for the beginning introduction, when we applaud, we don't just do it with our hands. It's not just clapping. We're also whooping, and we're also stamping our feet, which I can't really do on the stage because I have to, stay standing. I don't want to fall over. So, if we could just practice that one time before everybody gets going, can we have a big PyCon UK round of applause? Yes! Yes, that is so much better. Thank you very much. So, each talk is limited to 5 minutes. The talks can be shorter than 5 minutes, but sometimes people get up to the edge of that 5-minute mark. And when they do that, I'm going to start walking onto the stage. When they really hit just kind of the last 15 seconds or so, I'm going to start to do this. And you can't hear that from where you are, but if all of you do this, just tap your index fingers together, it makes a kind of really disturbing, annoying sound. It really stops you from being able to think. And so that is essentially the cue for the speaker to finish their sentence before I start off the big round of applause, which they will not be heard through, and is essentially the indication that they've finished. We don't tend to cut off the microphone here, but we will if they're still speaking after the round of applause has finished. So with that, I would like to welcome our first lightning talk of the day, Chris Lafra from JP Morgan.
Hello, everyone. My name is Chris Lafra. I work with JP Morgan. We're the main sponsor of this event. A couple people have asked us, why are you here at this event? Why do you have a booth here? So we care about people volunteering all their time, doing the organization here, basically at no personal gain, doing volunteering work, and we want to compensate for that effort by donating money. This is the real reason why we're here. Of course, we're also hiring, but that's not why I'm here. I want to make new friends and learn about new exciting stuff happening in Python land. So my history has been in both technology and in finance. I've worked at Bank of America on the Quartz project and now at Athena and JP Morgan. But before I left Quartz, I interviewed with Google. And to prepare for my interviews, which is really hard, 10 years ago, we all have to do work. So what I started doing is studying computer science algorithms. And yeah, I've done sorting before, but yeah, to know the difference between Q-sort or quicksort and bubble sort, do we actually really know that? I started trying out, experimenting with them, and before I knew, I was like, yeah, I want to really show what is going on inside the algorithms. And this went overboard a little bit, so I wrote a site with 50 computer science visualizations. So yeah, there's quite a few of them here. And I basically wrote a DSL so you can make visualizations. So we have some troubles with the cable, which is not my fault. It's whoosh, don't touch anything anymore. Very quickly. So what does the visualization look like? So on the top left, we have an algorithm. So let me make the font a little bit bigger. So you can see this is depth first search. We have a tree, which is declared at the top. And then at the bottom of this view, we have a visualization script. And you can write any Python. In this Python, you can refer back to the variables that are declared up here. And you can do things, like draw a circle, draw some text. So that's the DSL part. And when it runs like on the top right. So I'll hit the play button here. And you get an animation of the actual execution of the program. So when I zoom out a little bit, you can see both the code and the visualization. So when I run play, you can see the line that is executing. And then at each line, the visualization script at the bottom is run. So this is really a movie of, what is it, 514 different, basically frames of visualization. So if you scroll back, you can see, now this is depth first search. So if you see the orange ball go up and down, it goes in this like vertical pattern. And I want to show you breadth first search, which is very similar, like code looks like identical, but if you want to explain the difference between the algorithms and you go like this, you can actually see the pattern of these horizontal lines rather than the vertical lines. So this is where visualization helps, is to understand how the algorithm works internally. And I have some other examples, like this, for instance, is calculating pi. So we do this, play. So this is based on estimating the circumference of a circle based on drawing the rectangles inside and outside. And you go like, you make it smaller and smaller. So each step you go, you get closer to pi. So this is far away. You see there's a big error. But the closer we get, the error goes down. And you only need like maybe 6 or 7 or so steps to get like really reliable. And this is what Archimede did by hand, more than 2,000 years ago. So the Greek philosopher, he did 2,200 years ago. And he went as far, I think, as 700 digits. So this is, he calculated all of this by hand. This is just amazing. Today we can just write a little Python script, right? That's much easier. This one I really like as well. This is Fibonacci. We all get that in interviews, right? Can you write a Fibonacci? This shows that you can do recursive programming. But of course in Python we don't write recursive Fibonacci because that would be really slow. But we write one that has a generator. So this is a generator function that produces one at a time and it remembers the last two so that it runs really fast. But what not a lot of people know is that Fibonacci is actually closely related to the golden ratio. And you do that by calculating, dividing the previous, the current Fibonacci number by the previous. So if you calculate the next one and you divide this number here by the next one, you get 1.6 whatever. And that is the golden ratio number. So if you look closely, you can see broccoli here. The red line is just like this is the shape of everything alive, or whatever. So this is nice. This script is, what is it? Like 20 or 30 lines to visualize something as complex as, this Fibonacci sequence going on infinitely. Now the way this works is it's a profiler running on the Python code. It sets a breakpoint on every line. And at each line, it runs the visualization script at the bottom. It collects all the renderings that you want to have done, and then it gets sent back into JavaScript. This runs on a server, so this is AppSpot. So this is, so far, I launched this like 10 years ago. Nobody has abused it yet, so I'm just hopeful that it will not happen, but we're in the process of converting this to Pyodite right now, because there's no reason why you would run this kind of algorithms on a server, right? It's just setting me up for all kinds of disasters. So if you want to try this out, go to pyalgoviz.appspot.com. And quite a few people have added their own algorithms. If you want to experiment with that, just want to browse around, that would be fun. I haven't done anything to this site in the last 9 years, and this is amazing, actually. It hasn't broken yet. So I'd like to see what you built. Thank you.
It's quite overwhelming, isn't it?
Yeah, that's amazing.
I think you have...
Run away. We're going to donate one of these snakes, which you can find at our booth. A lot of people like them, so we're going to donate them to the best lightning talk. Not myself, of course, but so the best one. And we still don't know how to decide. So Mark and I will decide, but maybe you can all wave in as well. So we listen to your applause, and the louder it gets, hey, this is a contender. Let's do
that would be an anarchic end to the day, I think. We'll have to see how that works. Okay, Quentin, if you could come and set up. Quentin is going to be our second speaker. Our third speaker is Marc-André Lemberg. Could you come to the front, please? Oh, you're already here. That's fantastic. Professional there. And then our fourth speaker, Michael Bezdowski. Did I murder your surname? That was a yes, just in case anybody didn't hear that. So how are you doing? It looks like you're ready to go. So without any further ado, this is Quentin. I'm going to murder your surname. This is Prade?
Yeah.
Oh, excellent. And this is about testing HTTPS in Python. Take it away.
Thank you. So yes, trust me. Let's say you wrote a cool network library. And so it could be an HTTP client, say like urllib3 or requests, or a client for a service like Elasticsearch or Kafka. And you will need to implement SSL TLS support. And as we've seen earlier today with the Kafka example, we had to configure HTTPS, so it has to be implemented in the library. But how do you know if it's working? Right? So is it working at all? And do you handle edge cases? Like, I also had a bug where the certificate was tied to an IP address and my code broke. I also broke client certificates in the past, intermediate certificates, and many edge cases like that. So there are various ways to address this. So the first way is to actually test it manually. So you will generate certificates manually and then run the code by hand. But I don't want that. I want to do that in my test suite and test it on every commit and every pull request. You could also store the certificate as binary blobs, which was done in urllib3 in the past. But this means that you store binary blobs in Git, and they are not readable. Like, you need to open SSL to know what's inside, and it also makes it hard to update when rules become stricter. So I lost a lot of time trying to understand why macOS refused to run my test suite when I updated it, and yeah, the rules become stricter, and I had to figure out which rules. It was a lot of pain. So trust me, why is it better? So you can run the test as part of your tests. You run PyTest and you just have everything tested, including your TLS HTTPS configuration. The code will be easy to read and modify, and it will work with the latest version of macOS. Debian, for example, Debian requires, like, the key is like more than 4K bits, and yeah, if you don't know that, then it will just fail. So yes, code. So this is simplified, but basically what we do is that we call trustme.ca to generate a certificate authority, and then we write it to our disk. Then we do the same thing with the server certificates. And again, we write them to the disk. So at this point, we have this root certificate that is not trusted by anybody, but that we will trust in our test, which we call that trustme. And this certificate authority generates a server certificate that will be used in our server. So now what you have to do is to create a server with this server certificate, In that case, I'm using a nice PyTest plugin called PyTest HTTP server. And I just tell this server to answer bar when I ask for foo. And then I just do that request and check that I have the correct answer. And this is it. You have a test that uses TLS, and you can really test every edge case that you want to. Thank you.
Steve Dower around? Oh, no, there he is. He's just hiding behind the door. It's fine. Do like to have people here when it's their time to speak. How's it going? Nothing so far? There you go. So this is I Made a Thing?
Yeah. Yeah, slightly changed the title last minute.
Oh, fair enough. I'll let you go.
Yeah, so my name is Michał Wesołowski. That's how you pronounce it. So I had a problem, so I made a thing. We are engineers, so that's what we do. If we have a problem, we make things. So I work for a company called Bluesmith. We're a software services provider based in Leeds. And we work with a number of clients, and often even a number of clients in the same week and even in the same day. So my typical day or week would look like this. Each client has a separate color on those pictures, and you can see that there's a lot of switching between clients and projects during the day. So I tried to find a solution for this problem, because we charge clients for every hour we spend working for them. So it's important to track that accurately. So first of all, I started with Notepad, but obviously that didn't work great because I couldn't do reports. Then Excel, and that was just too much overhead. And then I don't know if you know the tool Toggle, but it's a great tool. I found it, which allows you to very easily track time. It's a tool customly built for this purpose. It allows you to track time spent on projects, tasks. It gives you great reports. It's cross-platform. It allows you to track time based on the programs you use, so it automatically switch clients. And it has a useful nagging feature, so that when you don't track time, it nags you to start tracking that time. So the downsides to Toggle are that it's a program. So in order to change a task, you have to find the window with Alt-Tab, and then you have to select the task. So you lose an entire 5 to 10 seconds to do that, and you do that multiple times a day, so it adds up to a minute or two. So that's a lot of time. It's easy to forget to track because it's in the background somewhere, so sometimes you might forget to switch a client, and hence bill somebody more than you should. And it's tedious to check on, so that you know how much time you spent already. So I've created an over-engineered solution to this problem. This is a box. I think an official title is PyTracker. I think it will stick in my company when I get this presentation. So basically, it's a small computer. It has a screen, a small LED matrix, a keyboard, you can say, with basically 15 colorful buttons, on and off switch, and status LED. And this is what's in the back. You can see that this is my first big Pi project. There's a bit of a mess here and there. I'm not that great at soldering. And then there's the Raspberry Pi 4. So what it does is basically, this is a Toggle is a desktop application, and this is basically like Toggle but physical. So when you press a button, it changes a task and then displays that new task on the screen along with the time that you've already spent on it. So you can constantly see how much time you spent on a particular thing. And the way I designed it is that each button corresponds to a given client. So, I had I think 10 of those buttons were programmed, so I would remember which one was which, and then, instead of having to look at the program, I would just click a button on this box. So why did I do this to myself? Well, it was painful, over-engineered, and absolutely not necessary. But mostly I did it just because it was fun. You know, it was Python, it was Pi, so it was, I think, the easiest way to do it, and it was fun. And it allowed me to solve the problems, which is, you know, I knew what was going on at the time, all the time. I always knew how much time I spent on a client, because some clients don't have much budget, so you have to be very careful. It wasn't tedious to change a task. It was actually fun, you know, pressing those buttons. For the first few days, I was just pressing buttons without actually, you know, switching clients, because it was just fun. And it's hard to forget what you're working on if something that is constantly, you know, blinking at you, because I made it blink. So the reason why I shared this story with you is because I wanted to maybe inspire you to tinker with stuff, because I think it was a lot of fun. Raspberry Pi is the easiest way to start doing stuff like this. And there's a session tomorrow that I'm not doing, but somebody else is doing, which actually introduces you to programming on Pi and doing some mechanical stuff. So maybe if you fancy stuff like this, you might want to attend it. Thank you.
Oh, lovely, keeping that energy up. That's fantastic. Yeah, you're taking orders, Michael? No? He's not paying attention. I think that was cut down from a 15-minute talk. Is that right? So cut a 15-minute talk down to 4 minutes. It can be done if you speak fast enough. No, I love that. That was funny. Thank you. When is a tractor not a tractor? When it turns into a field. Yes. None of them are good. You don't really want the tractor jokes.
Is it going to go? Yes.
So,
lovely.
with that, I'm going to pass to Gail, who has a talk called Sending Home.
Okay, so I would like to read to you from this book, Going Postal, by Terry Pratchett. You may be familiar with it. In Going Postal, there is a communication system known as the clacks, introduced in an earlier book, but it appears a lot in Going Postal. It's basically a semaphore kind of system with shutters on a tower, visible from a distance, with operators operating the signals, so it switches between basically noughts and ones with the shutters open and shut. So a chain of those gives you a communication system. So that's the system we're talking about in here. She was known as Princess to the men on Tower 181, although she was really Alice. She was 13, could run a line for hours on end without needing help, and later on would have an interesting career, but anyway, she remembered this one conversation on this day because it was strange. Not all the signals were messages, some were instructions to towers. Some, as you operated your levers to follow the distant signal, made things happen in your own tower. Princess knew all about this. A lot of what travelled on the Grand Trunk was called the overhead. It was instructions to towers, reports, messages about messages, even chattered between operators, although this was strictly forbidden these days. It was all in code. It was very rare you got plain in the overhead. But now, there it goes again, she said. It must be wrong. It's got no origin code and no address. It's overhead, but it's in plain. On the other side of the tower, sitting in a seat facing the opposite direction, because he was operating the upline, was Roger, who was 17 and already working for his Tower Master certificate. His hand didn't stop moving as he said, "What did it say?" There was GNU, and I know that's a code, and then just a name. It was John Deerhart. Was it a... You sent it on, said Grandad. Grandad had been hunched in the corner, repairing a shutter box in this cramped shed halfway up the tower. Grandad was the Tower Master and had been everywhere and knew everything. Everyone called him Grandad. He was 26. He was always doing something in the tower when she was working the line, even though there was always a boy in the other chair. She didn't work out why until later. Yes, because it was a G-code, said Princess. Then you did right, don't worry about it. Yes, but I've sent that name before, several times, upline and downline. Just a name, no message or anything. She had a sense that something was wrong, but she went on. I know a U at the end means it has to be turned around at the end of the line, and an N means not logged. This was showing off, but she spent hours reading the cipher book. So it's just a name, going up and down all the time. Where's the sense in that? Something was really wrong. Roger was still working his line, but he was staring ahead with a thunderous expression. Then Grandad said, "Very clever, Princess. You're dead right." "Ha," said Roger. "I'm sorry if I did something wrong," said the girl meekly. "I just thought it was strange. Who's John Deerheart?" "He fell off a tower," said Grandad. "Ha," said Roger, working his shutters as if he suddenly hated them. "He's dead," said Princess. "Well, some people say," Roger began. "Roger," snapped Grandad. It sounded like a warning. "I know about sending home," said Princess, "and I know the souls of dead linesmen stay on the trunk." "Who told you that?" said Grandad. Princess was bright enough to know that someone would get into trouble if she was too specific. "Oh, I just heard it," she said airily, "somewhere." "Someone was trying to scare you," said Grandad, looking at Roger's reddening ears. It hadn't sounded scary to Princess. If you had to be dead, it seemed a lot better to spend your time flying between the towers than lying underground. But she was bright enough too to know when to drop a subject. It was Grandad who spoke next, after a long pause broken only by the squeaking of the new shutter bars. When he did speak, it was as if something was on his mind. "We keep that name moving in the overhead," he said, and it seemed to Princess that the wind in the shutter arrays above her blew more forlornly, and the everlasting clicking of the shutters grew more urgent. He'd never have wanted to go home. He was a real linesman. His name is in the code, in the wind, in the rigging and the shutters. Haven't you ever heard the saying, "A man's not dead while his name is still spoken"? So, when the author Terry Pratchett died, this message circulated a lot on the internet, still does. I would always share it when I saw it. It was also always shared by this man, whose name we should keep circulating in the overhead. GNU, Russell Winder, a very great friend to me, to many people here, to this conference, to many conferences. A great man. Rest in peace, Russell.
Yeah, Russell was actually the speaker for the first Python talk I ever saw at a conference. So he had ripples out in the community. So even if you haven't heard his name, he's had an impact on you somehow. So Steve is plugging in a Windows laptop, so we don't know what's going to happen right now.
Not the first of the day, though, so someone else made it work.
Oh, excellent. Might have a slightly dodgy cable there.
Flickering here is looking bad. Tell another joke.
Really?
Either that or I will, and you prepared for it.
Let me see. Well, there's a farmer who lives at the end of my road, and he was driving his tractor down the road, and then he turned it into a field, and it immediately got stuck. It was a mystery until we discovered it was a magnetic field. I think I might actually know some worse ones. Yes, what was I going to say? So we are running late. That was our fifth talk.
There we go.
I will finish that thought next time. So, Steve, take it away.
I'd like to play a little game. It's called Spot the Vulnerability. This code has an issue in it. I know it's not real easy to see, so let me give you a hint. There's only one line of code on this slide. And there's actually nothing wrong with the assignment either. Why is this a security vulnerability? Let's chat about ints. How big is an int? So a byte we generally consider to be 8 bits long. 2 to the 8, 256 different values for that number. 16-bit machine, you may remember some of those. Get you up to 65,000 values in a single number. 32-bit, more typical, is up in the 4 billions, but probably the one you've all got on your lap right now is a 64-bit machine, which means your int is going to get up to whatever that says. But we're in Python here, so we can keep going. So let's do 1,000 bits and have a look at the number that we get for that. I'm not going to try and read that one for you. But we can keep going even further. What if I do 2 to the power of 1,000,000, 1 million bit number? This is about the first 5% or so. It's 300,000 digits long. Where is the vulnerability here? Most languages don't consider this an int anymore. You're in some special type of number, but for Python, the standard int type will let you go this big. And the difference here is this isn't instantaneous. It's instantaneous on the slide, but when I ran it, it actually took some time, and I sat there waiting for it to calculate how to display it. For comparison, let's look at some timings. If I use the timeInt module and we'll compare a byte, a single byte, 2 to the 8, that converts to a string in less than a microsecond. If I convert the string back, that's less than a microsecond. That's really, really quick. You're not going to notice that. If I take this 1 million bit number, 300,000 characters, that converts to a string, at least when I did it, in 2.5 seconds, and it converts back in 0.6 seconds. Not microseconds, not milliseconds, seconds. We're 6 orders of magnitude larger here. You can't do it twice within a second. If you prefer charts, a quadratic algorithm looks like this, and that's the kind of algorithm that Python's int to string conversion uses to get from decimal numbers to the binary representation and back again. The longer the number, the longer it takes, but it takes longer, faster than the number gets bigger. So the vulnerability here is we're taking some data from outside of our application, some kind of request. Someone's fed it to us, and we're converting it to an int. And if they pass in a really, really big number, our program's just going to lock up here at this int for some unspecified amount of time. 300 kilobytes worth of number is going to lock you up for a second. If you accept a request bigger than that, you're not going to do it. So the fix would be to check the length before you do the conversion. But that's not really going to work, because now you've got to add that check every single place you use int. Every single library you use that uses int, you have to add that check. It goes on forever. So rather than showing you a vulnerability, I'm showing you the mitigation. Because what's changed in the most recent set of CPython security releases, all versions 3.7 onwards have had a security release with this fix, is that int may now raise a value error when the argument is too long. Similarly, so does converting an int back to a string. Now, I know that sounds scary. What this means is there's a global value that sets what that conversion factor is, which gives you the ability to control that. But it also means that you can just assume that if you're running on the latest Python, you're protected from someone feeding a massive number into your app and locking the whole thing up. But Steve, I'm already safe, you say. No, you have an unexploded ship in your code. But if you really are safe, it can be disabled globally. You can also change the limit. Again, globally. This is not currently meant to be mitigated by each individual library on its own. If your application regularly deals in really large numbers and you need to fill up consoles and consoles worth of space with your number, go ahead and turn this off. If you're a library that does conversions, please don't turn it off. Let the person who's calling you adjust it if that's what they need to do. This has been a very, very quick overview of CVE 2020-10753. If you have more questions, feel free to come and find me. If you'd like to bring arguments, please come prepared to pay, but I'm happy to provide contradictions for free. Thank you.
So we have Joaquim next. Joaquim, can you stick? Yep, awesome. And after this, we have Alex Comey. So Alex, is somebody? You're Alex. Excellent. Yes, if we can't get to the last talk of the day, that'll be the first talk tomorrow. So we'll just let them run over. We used to just kind of scrap the cards at the end of the day, and then people had to reapply the next day, but that seemed kind of unfair, given that if a talk's accepted, people might spend the afternoon working on it. So yeah, we roll those over.
Sorry, this is taking a second.
No, that's good. You're nearly there. I don't know whether to start my next sentence. Excellent.
There we go. Hi, I'm Joachim. I'm from the Danish Business Authority, and I will be talking to you about bombs for peace. I got a little bit inspired by the excellent talk this morning, so this is a bit of a follow-up on the unexploded bombs. A few thoughts on how bombs can actually help you towards building a more stable system. And before we get into that, a quick reminder on idempotence, that the strict mathematical definition is written here, that if you take a function on some variable, you get an output, and then if you take the function on the function of the input variable, then you should still get the same output. So the classical example in math is like you take the derivative of e to the power of x and you get e to the power of x, and if you take the derivative, you end up there again. So in a bomb analogy, you could think of the function as the trigger system, and then the input variable being the bomb, and when you explode that, you end up with an exploded building. So if that is idempotent and you do it again, then the function just runs on the output of the old system, and you end up in the same state that you were already in. Okay, that's the sort of basics of that. So let's go back to this morning. And Hannah said to us, look at the state of the system, look at the wreck, and figure out how did you end up in this miserable state. So how do we get here? That's about information about the system. Can we get here again? That's reproducibility. And what happens if we perform the same process again? So that relates to idempotence. There was a case about Terex 25 that unfortunately had some fatal consequences. This was a stateful system that the user could actively change the state of by input directly. So that's sort of a vulnerability in design. This could only be reproduced by a debugging process, and that was only facilitated by the very skilled workers that they had on hand, the nurse and the physicist, and they had extremely good memory, probably also a few logs of what had actually happened with this system. So be careful with that kind of system. So when you think about a state of some system, you can think of it in the analogy of a Goldberg machine. You start off with some alarm clock ringing, there's some balls rolling, and eventually you get to the pair of scissors cutting a string and the boot falls down. And this is an irreversible process. The string is cut, the boot is down. If you ring the alarm again, you're still in the same state. So this means that you can keep the process going and you won't change the system. So the thought is that you can have an idempotent and sort of stateless system, and if you build sort of your initial state by this idempotent architecture, for example, as you do with infrastructure as code, you can build a very delicate system and you will be able to recover it every time you run that setup script. And that means that you can now go ahead and explode the system as much as you want. You simply push the trigger, you end up in the ruined state, and your code can then rise like a phoenix from the ashes. So the few closing remarks: idempotence and reproducibility are not the same thing. Idempotent architecture can ensure this sort of statelessness in your design, and that makes all your systems easier to debug and maintain. And there's an honorable mention called Chaos Monkey that simply has the effect that it goes around and kills other instances that's running on the Kubernetes clusters. And that helps you build a really stable system that can withstand a lot of system crashes. So that's a good way of going about it. Thanks for your time.
Three minutes. Who's heard of the Pac-Man Rule as a conference rule? You got at least one hand. You got, yeah, that's not enough hands. You need to know about the Pac-Man Rule. It's a rule for conferences that make them more friendly to people who are new to the conference. So I had a lot of hands up this morning, a lot of people who have come here and maybe don't know anybody, and it's very difficult to just meet other people and get into those conversations. So the Pac-Man Rule states that when you're having a conversation with 3 or more people, you just leave a gap in your circle. The idea that that's a welcoming space that essentially anybody who overhears what you're talking about or just thinks you look like interesting people to talk to can just step into that gap and join your conversation. So it just generally, it's a nice thing to do that just adds to the community feel of our conference. I think tomorrow, if I see people standing in closed circles, I might just try and push myself in. Maybe tell a tractor joke or two.
Russell loved it.
Yes, he would. Yeah. I have a couple of Russell stories, but they were mostly about how he was very nice to me at a point where I didn't know anybody in the Python community. So. This is taking a while.
No, I know.
That's okay. Is it Linux?
Yeah.
Oh.
He's picked it up. Yeah, so it's there's a display, but it's just not showing.
There's a farmer near me. He's recently been mowing these perfect circles in his field. I think he's got a protractor. They don't get any better. They don't get any better. But I do start to run out by the third day. So if anybody has any suggestions, feel free to tweet them at me, or, I don't know, run up to me in the conference, tell me a tractor joke, and then run away again. That would be amusing but weird. So can we have a hands up again for people who are new to PyCon UK? Right, so if you're sitting next to somebody who's just put their hand up, keep your hands up. Hands up. You're sitting if you haven't got your hands up, in fact, even if you have, just if you're sitting next to somebody who's got their hand up, turn to them and just say hello. Introduce yourself. We've got some time. You don't want to hear any more tractor jokes. See, now, every person in the room who's new this year now has somebody they can nod at as they're passing through the conference hall. And that's how it starts.
Yeah. It's literally just come out.
So I think if this takes another minute or so, because I've run out of tractor jokes now, we're not having any luck.
No.
I'm afraid. I think we might have to move on to the next speaker
No
and then try again tomorrow. Okay. Well, that was a good way to start a conversation, wasn't it? Could we have our next speaker, please? This would be, I'm not doing a very good job of lining them up today, Mark Bell. Mark Bell. Oh, fantastic. Thank you, Mark. And then we'll have Ian Tempest next, and then I think that's going to be our last speaker of the day. So we've got 9 minutes remaining. Oh, Mac, that'll work. One more thing. So tomorrow we'll have the buckets out. Please write talk descriptions and stick them on cards and stick them in the appropriate bucket. When, at lunchtime, we take the buckets away and put the cards up on the flip chart, so those are the selected talks, it's really useful if you could come along in the afternoon, and if your talk has been selected, could you just put a tick next to your name? Oh, and don't forget to put your name on the card. That sometimes gets missed as well. And that just means that we know that you've seen that you're going to be here and you're actually going to be prepared to speak. There's lots of just waiting for this to go away. Oh, there we go. Don't think Optoma are doing themselves any favors there. Okay. I'll hand over quickly. Go for it.
Fantastic. Thank you very much. Hi, everyone. I'm Mark. That's not the important thing. The important thing is discuss.python.org. So there's many of you here, but how many of you are signed up for discuss.python.org? I don't know about you, but I get asked a lot of weird questions, exotic things about the Python language, things that I don't understand. And this is a fantastic resource. This is the thing that helps me debug everything. So in terms of things that are going on in here, I guess the thing that we can even draw on just from the speaker before, things like inside of core development to the Python language, let's just see if it will connect through. That's okay, I've got it cached. Things like that conversion between ints and strings taking a long time, that's something that's being actively discussed right now. There's 172 posts on there. If you're not involved in that, if you aren't one of those 172 people, then have a look. See if there's something in there that you might contribute to, that you might get involved in. I guess in terms of the things that are cropping up in this particular space, things like that quadratic algorithm that Steve mentioned, yeah, let's try and do something about that. And this is a place to get together and organize and figure out what that plan is for going forwards. Now, there's many of you here, but in terms of those who are involved on discuss.python.org, the numbers are much lower. There's only 218 people who have even completed the autobiography section of their profile here. There's more than that in this room right now. So why not get involved? Why not put your profile on there and see what you can contribute to the community as well? Thank you very much.
Woo! See, there really is something fantastically valuable that you can communicate in a minute and a half. So thank you very much for that, Mark. So now we've got Ian Tempest is going to be talking about beautifully decorated Python. And I think we're going to finish more or less to the minute on time, which is going to be great. Although I suppose I shouldn't really tempt fate. It's got all the dongles, we've got the cables, it's all good. I don't really have anything else to talk about. Maybe that was obvious when I got you to all talk to each other. That's sort of the last escape for somebody who's on a stage and doesn't have anything to say. Do I have another? Oh, I had a tractor joke, but now I'm going to have to tell it tomorrow. Oh. That's... We're nearly there. Another adapter. Has anybody been watching that new TV show where farmers compete against each other? It's called The X-Tractor. So you don't have to applaud that. You don't have to applaud that. I apologize. That's actually my last tractor joke of the day. The reason I tell tractor jokes is actually because Harry Percival, who's sitting in the third row here, used to do the emceeing of lightning talks at EuroPython and used to tell one tractor joke over about 2 or 3 days. So when you get to that punchline, it was even more disappointing. He said it first. Right, so we got the slide up. Go for it.
Okay. Good evening. Hello, everyone. My name's Ian Tempest. I'm a senior engineer at Darwin, which is a motor insurance brand, Direct Line Group. I can almost pronounce the name of my employer. Just a little bit nervous. This is my first time at PYCON UK, and my first time speaking at a conference. But this talk I prepared a few months ago for some of my colleagues at DLG. Beautifully decorated Python. So in the next, or probably I'm down to about 4 minutes now, going to talk about decorators from quite a basic level, what we could use them for, and how to write them. Decorators, they don't literally decorate our code. They do not make it pretty, literally. Decorators add behavior to a function that you've written or that somebody else has written, and you don't need to change that function's code to do that. You do it by injecting a little bit of code before, a little bit of code after your function. It makes it very good for logging, for benchmarking, for caching or memoizing the results of your function given certain inputs. It's an easy way to add a simple authorization layer. You can do validation of inputs. We use it for unit testing and patching and so on and so on. There's a lot more complex stuff that you can do. So let's look at what it looks like to decorate a function, a very boring function. Let's calculate the tax you might pay on a particular salary in a particular tax year. If we wanted to do something simple, like make sure that we only provide integers. So my function was annotated to expect integers, but obviously Python doesn't enforce this. So we've got a function that we want to decorate. We've got a decorator called strictly integers. And this is how you create a decorated function. So now when we run this function, we get a value error because 55,000.00 is a float, not an int. And we can see that if we change our argument to an int, then it works again. There's a much nicer syntax and one that you're going to be more familiar with. Stick an @ symbol, the name of your decorator function, and now every call to your function will have that decorator applied. So how do we write a decorator? Let's look at the strictly integers decorator. If anyone was in Don, well, I'm sure a lot of you were in Don Weldon's talk earlier on callables, this is going to look a bit familiar. We have a decorator is a function that accepts your function as its argument. But this is where the magic happens. This is the wrapped function. We pass in, we expect star args, star KW args, which is to say that this function accepts any combination of positional and keyword arguments. And at the moment, this decorator wouldn't do anything. It's just calling the function that you put in and returning the return value. We can add extra code before our function runs. And we could potentially add some more code after the function has run, as long as we return the return value. So some examples, we've got the strictly integers decorator to do validation or type checking on your inputs. Another example might be to log the calls to your function so that you can get some neat debugging info in your logs, recording anything you like about what was sent to your function or what it returned. Similarly, you could just be timing how long your function takes to run every time just by sticking the @benchmark before your function. You could add an authorization layer with a parameterized decorator like this to make sure that only those who are authorized to do so can run a particular function in your code. You could use a function to memoize or cache the results of your function given certain inputs, so that on the first run it takes as long as it takes, on the second run it takes much less time. This particular decorator, LRU cache, the least recently used cache, is built into Python. You can do import from functools, and it's right there. It really is as easy as I've put up here to implement in your code. Just to finish off, I mentioned at the start that you can't use decorators to literally decorate your code and make it look pretty, but let's do that anyway. So we can use inspect to grab the source of whatever function we put in. We can use the standard ANSI color codes to highlight your code on the command line or your Jupyter notebook or wherever it is that you're running this code. So let's turn our code into a rainbow. There's a few more color codes I had to add and a little bit of logic to work out how many lines get in each colored stripe. We take the most boring function I could think of to calculate P60 details. There it is, undecorated. Let's rainbowify it. And I should mention that I wrote this in June, which is Pride Month, so it's not just any rainbow.
What a great end to the lightning talks. Thank you, everybody. Please submit your talk suggestions for tomorrow. Can I have a big round of applause for all our first-time speakers tonight? Oh, we've maybe got a prize.
So the decibel meter went really high for Russell's memorial, but a little bit higher for the PyTracker. So congratulations.
So I will see you again this time tomorrow with some more fantastic lightning talks, and Anne is just going to close out the day.
Absolutely. Sorry, got told off earlier for not standing behind the microphone, so I'm now standing directly in the light, but behind the microphone. Just to say thank you to everybody. This is the close of proceedings today. Go and make friends with people if you're going to go out in Cardiff later. I'm going to borrow from Park Runs, hashtag DFYB. Don't forget your badge in the morning, otherwise you will not get back in. City Hall is open from 8. The schedule will start from 9, and if you've got any tractor jokes for Mark, he's at Judy2K on Twitter. Thank you very much, everybody. Enjoy your evening, and we'll see you tomorrow.